Okay, welcome to the tracking and sorting or diverting simulation for the semester. What you see on my screen is a software package called FactoryIO at the top. I've created a loop conveyor, as you can see. There are some boxes on it. There is an RFID reader back here in the back side on this little overhead piece. We can go down there and look at that real fast. And so there is the RFID reader as the overhead. Here is one of the two photo eyes that are used to help control that. The left one is the trigger for the RFID reader. The right one is for controlling the information and putting it into the FIFO array. The conveyors will move the boxes around clockwise, and this unit here, each of these are push diverters, and they will push the boxes off the conveyor as required based on the logic in the PLC. This is connected to a Compact Logix L23 PLC at the moment, but it could be connected to really to anything you want that's supported by the software. The software does do a very good job at physics and showing the correct way in which the boxes are going to interact and the diverters interact. It is a little bit limited in that I don't have a lot of control over what I can use, what parts are in here. I can't add new items necessarily. But that's okay. It does a very good job of simulating the inputs and outputs, which is why I chose it, and it will allow us to write ladder logic against a virtual device that is reacting in a fairly realistic manner, which has been the challenge as far as finding something that does this well. Most of the simulators out there are well written, but they don't necessarily have the entire instruction set, or it's a modified instruction set or something else, whereas this allows us to continue to use the normal RS Logix 5000, Studio 5000, 500, whatever we want to use to program while providing a virtual hardware environment for the other side of the PLC. The goal of this simulation, you can see in the lower right of my screen here, is that we got stations 1 through 6, and they are 1, 2, 3, 4, 5, and 6 up here, and we're going to divert the box based on arbitrarily the mod 7 of the ID value that the RFID reader is generating. These boxes are not pre-coded in the traditional sense as far as information. It is an incremental index of some sort that the software, the FactoryIO, has generated for the RFID tags, and I believe it's really an object counter more than anything else, but not quite. If for whatever reason a box is not read, and sometimes that does happen, I'm not sure why, but if it does go past through my little scan tunnel and I don't get a valid ID out of it, or any ID out of it really, I'm going to assign it a -1, and it will go around again. Otherwise, it will be diverted at one of the 6 locations, and the way the divert's set up, the mod 1 goes here, mod 2, 3, 4, 5, then mod 6 and 0 should be diverted out of the last slot here. So without further ado, I'm going to start this up so you can see it running. And this HMI interface down here is something I threw together to allow you to see what's going on and also to make it easier for me to control things. And you can see the boxes are added to this first FIFO queue, and then they're being stepped through their subsequent locations as needed. The So here's the last one coming out of, it's going to come out of this one here because it's 4. And as you can see, it does a nice job of that. If we scroll back, you can actually see the boxes on the floor. And as the boxes are added to, you will actually see them when they hit each other, they will move and they react to each other, which is nice. Not needed, but it's nice. So mod 5, mod 6. And so this is why I believe it's just a straight counter that's tied to the identifier on the object. Sometimes the software will send duplicates. I don't know why, but it's not a problem for the way we're trying to do things. So there, as you can see, when it ejects it, the boxes hit each other. They are responding and reacting to each other. The way my logic is set up, there are, get this view fixed here. There are 2 sensors here. There's another one here. There's another one there. And in front of each subsequent divert station, there's a photo eye. This first one adds the box that came through to this general FIFO queue. This photo eye moves it from this queue to the station 6 queue. And when it hits station 6, it processes the box ID, decides whether or not to divert it. If it does not divert it, it moves it on to the station 5 queue, station 4 queue, 3 queue as needed. And so there is 192. It's going to divert to 4. So it's in the primary initial queue. It's moved to that one, this one. Don't divert. This one, don't divert. This one's going to divert, and so it's going to disappear. It never goes to 2. And there it disappeared, and then it gets kicked off. The way this software actually works, FactoryIO software, is I create I drag the objects I need in, and then I create a series of connections, and we have inputs and outputs, and so these are the binary inputs and outputs. There are also floating point and integer inputs and outputs available. It does not support strings, so it is limited that way. I've got my sensors on one side, my actuators on the other, and so to put something into input 0, which is this first one here, I just drag whatever it is I need over into it. And then these are for compact logics and control logics, really any logics unit, and I believe for the micro 800s, these are the tag names. And the way this works is I give it a tag name, I tell it if it needs an offset, and then how many tags I want to create. In the PLC, I have to use this exact verbiage in my tag name, and I have an underscore after input, and then it'd be 0, 1, 2, 3, up to 31. Same here. Here are my floating point inputs and outputs, and then my integer inputs and outputs. This is a brief view of the logic on how the decision-making process occurs. And so this is for station 6. It's the first station coming out of the curve. And they happen to be normally closed output or inputs, excuse me. And so we're checking to see if the input has been triggered. We're making sure that the timer is not currently running. I found I needed this to keep it from trying to double execute stuff. I'm doing a not equals. So if it's not a divert point, in this case it will be. Well, no, in this case it's not because there's the current value is 0. If that's true, I need to move the data from the station 6 queue into the station 5 queue. So here's my FIFO load to do that. I then unload from station 6's queue that first data set, or that first box, and that's what that's doing. If it were to be equal, and I wanted to divert, so this is do not divert, and this is divert. If I do want to divert, then I start a timer, and we'll latch that in, seal that in, and then I unload it from the queue, from the station 6 queue. Note, I do not add it to the station 5 queue because there's no reason to pass it on, since I'm not going to use it anymore. The pushers have state sensors as well, and so I can tell if it's extended or retracted. And so I seal in my timer until it's been fully extended, at which point it'll retract. And then this is just, this timer is a delay so that the box has a chance to move in front of the pusher. When it's done, it fires the pusher, and the pusher goes until it's extended. So hopefully this has made some sense to you. Bring our thing back up here. And as we have been talking, the system continues to run. Yeah, there's a whole factory, and I just got this tiny little conveyor in it, but that's fine. This arrow is the magic box that adds new products into the system. There are other product options available, but I found these boxes seem to work best in my experimenting with software. Hopefully this makes sense. If you have any questions, feel free to get with me.